demonstration.
Thank you, Justin. While I'm getting my screen set up, I'll introduce myself. Like Justin said, my name is Joe Ludeman. I am a territory project engineer with ADS covering the Northeast Territory that encompasses New England, New York, New Jersey, Pennsylvania. So I work very closely with both Kyle and Justin on a lot of their projects and facilitating some of the more technical aspects of those projects. As long as everyone's seeing my screen, I'll get going.
Yep, we got you, Joe.
Awesome, thank you. So I'll start by kicking off on the ADS website. I'll navigate to the design tool and then get going from there. So to get to the design tool, we can hover over Water Management Solutions and click on our StormTech sub bullet. And that'll load sooner or later with any luck. There we go. Then under StormTech, we can click our design tool header and then launch our design tool, which will open up in a different tab. So I'm gonna X this out. I have a few other tabs loaded, but just wanted to walk everybody through how to get there. Another quick blur before I get going is I wanted to bring up the importance of everyone's feedback from the design engineer perspective. If you've been using this tool for a while, you may notice it's been growing quite a bit over the past few years, and that is primarily a function of all the feedback we received from you all. So just wanted to reiterate, your feedback's very appreciated, and if you ever feel inclined, you can use this contact us field at the bottom to give us some feedback. So without further ado, I'll get into our first design in our design tool and then subsequently model that in Hydraflow. So you can see that I've already preloaded a background image using this import PDF tool. The scale of this is 1 to 20, which I was able to input in here, and we can check by using this little length measurement tool right here. So now that that is all set, I'm going to input my parameters for this project. On this project, I know that I have enough space to use the MC7200 chamber, vertical space that is. So I'm going to go ahead and select that chamber. Other requirements on this project are a storage volume of 18,000 cubic feet. And I know that my max footprint that I can have is about 140 feet by 45 feet. I'm going to stick with the typical 12 inches of stone above and 9 inches of stone below. And my base of stone elevation is going to be 1161. So now that I have these parameters set up, I can hit Generate Design and watch the design tool work its magic. So here I am with this layout that was automatically generated for me. And I can use these fields at the top to see how everything compares to the parameters I set in. So we can see that the layout that I was given exceeds my volume goal by about 700 cubic feet, which is okay, but I think I can get a little bit closer to my target. So I'm going to head over to this Components tab and see if I can remove a few chambers to get closer to that. All right, so if I remove 1, I'm still a little bit above. 2 is still a little bit above, so okay, and then 3 is bringing me below. So what I'll do here is I'll go back to add mode. I'll add this chamber back. And while I'm doing that, I noticed that I didn't have an inspection port at the end of my isolator row, so I'll add one of those in there too. Just for to allow for surface investigation of the sediment accumulation in the isolator row. So here I am, about 95 cubic feet above my goal, so that's all right. I'm within my allowable footprint, and it looks like this layout may be good for me for the time being. So as a design tool user, being signed into my account, I can save my current project. And then another great feature that this tool showcases is the ability to email the drawing in report to myself. So I'm going to request this drawing. It typically takes quite a few minutes to process, but I ran through a similar iteration prior so I can show kind of what that looks like once that email gets sent. So you will receive an email with your layout that comes with a PDF and CAD file that showcase the design. You can see this is nearly exactly what I just modeled. And we're in AutoCAD, we're able to select these different blocks and modify as we see fit. Maybe if we're a little bit more comfortable using AutoCAD, this is a preferred option. And then you can see we also have our detail pages, layout, all this good stuff. So just wanted to touch on that briefly. But to get back into the design tool and how that works with Hydraflow, we can open up Hydraflow. So you can see here, I have two ponds pre-set up called rectangular and non-rectangular. The bed I just modeled is almost rectangular, so we'll call it rectangular for the sake of ease. And I can walk through getting that model going. So for anyone who may be more familiar with HydroCAD, Hydraflow is a bit less intuitive, I suppose you could say. HydroCAD has each individual chamber type all the way up to our brand new 7200s built in, whereas Hydraflow requires a little bit more input to model the chambers themselves essentially manually. The good news there is we do have a technical note referred to as technical note 6.35, which walks through the modeling of all of our different chambers in Hydraflow, including the brand new 7200 that can be found in the handouts tab of this webinar. And if you have that open now, you can maybe even follow along as I start going through this. So what we want to do is model our chambers. So we can start a pond, select the Chambers tab, and then start running through our parameters. So this invert elevation is the elevation of the base of our chamber. So since I set in the design tool, I set base of the pond to 1161 with 9 inches of base stone, my chamber invert elevation is going to be 1161.75. From our tech note, I know that the rise that will accurately model the chamber is 4.65 feet. Arch is the correct option. You have a few others, but as our chambers are arch-shaped, this would be the ideal option to select. The span of the chamber is 7.46 feet, again from that technical note. And the barrel length is 6.59 feet, also from the technical note. The number of barrels is going to correspond with the quantity of chambers that we have modeled. In this case, it is 60. An important caveat to note with this is I have 60 chambers, but the MC series end caps for the 3500, 7200, and 4500 all carry a little bit extra storage volume. So depending on how many end caps you have on a project, it may require for additional barrels to be modeled to account for that storage volume. So for the 7200 chamber, we're going to be adding about 2 chambers for every 5 end caps. So since I have 8 end caps, I'm just going to round up to 10, and I'll add 4 additional chambers in my barrel count. The slope of this system is 0 as it is flat. I'm going to select no for headers. The reason being is some of you may be thinking, oh, well, these systems do have headers. They have manifolds connecting the different chamber rows. That is the case. However, headers, when modeled in Hydraflow, are modeled as the exact same shape that you describe the chambers as, or the barrels. So for a 48-inch pipe system, it may make sense to model the headers because your header will be also a 48-inch pipe. But in this instance, it does not make sense as our headers for these systems will not be arch chambers. Stone encasement is yes, as we consider the volume stored in our embedment stone. Our bottom elevation will be the bottom elevation of the pond, not the chambers, so that'll be 1161. And then our width and depth parameters, we also are able to acquire from technical note 6.35. An important note is that the width that is given to us in the technical note is a good starting point. Because of the nature of Hydraflow, the width is the parameter that we will need to modify as a final step to achieve our desired volume. And we'll get to that in a second, but just wanted to precurse there. So from our tech note, we have 9.08 as our width, and we can use a depth of 6.75 feet. And then I'll update the void to 40% as is commonly recognized. So now that I have all my parameters input, I can hit apply and see what I'm looking at. So total storage 17,238. If we check back on our design tool, we're about 800, 900 cubic feet below that. So now here's where I'm going to need to go in and adjust my width. So there is a quick equation in the technical note that covers how to estimate your width, which would be equal to the area of the bed over the number of barrels times the barrel length. I wouldn't get too hung up on that right now. It's pretty intuitive once you start taking a look at it. And that's just me giving you a little bit of color as to where I'm going to take these estimates from as I modify my width. So again, we'll check back. We know target volume 18,095. So let me see, I know I'm less than that. So I'm going to go ahead and make my width 10 feet and see how that goes. 18,286. Okay, so now I'm a few hundred cubic feet above. We'll start to parse this down. We can do 9.90, apply. Still about 100 cubic feet over. Let's make this 985. A little bit high, 983. 18,092. I'm off by 3 cubic feet. I think that's all right for the intentions of my project, so I'm gonna run with this. So here I am with my Hydraflow node, modeling my pond, 6.75 feet tall, bottom at 1161, top at 1167.75, and my available storage is 18,092 cubic feet. And that is essentially how to model a node in Hydraflow. I'll take a quick second here to see if there's any questions that I may need to answer before going into another model that'll be a little bit less straightforward, and I can run through how to model that in Hydraflow as well. So with that, I'll start getting into that second model. So I got this preloaded as well. You'll notice the site is the same, but we've got a little light pole right here where our chambers were before. So this is just going to showcase a little bit of the helpfulness that the design tool allows for in accommodating, site constraints. So I'm going to up my storage volume to 21,500 because in this case I have a little bit more volume I need to achieve. Similar parameters for length and width. My base stone is going to be the same, and we have the same porosity and average cover. So let me see what it looks like when I generate my design. Okay, so this looks like it may be able to work, but again, we do need to consider this light pole that we have here. So like I was shown before, we can head over to our components tab and go to remove mode. And we know that, we don't want this light pole encroaching upon our system. So I'm going to go ahead and remove these two chambers to accommodate that. In this case, I'm also not particularly fond of where the outlet control structure lies relative to our downstream. So I'm going to chop this up a little bit and see if I can make a design that I think suits me better in this case. So let's do that. I think it's a little too far out here, so what I'm gonna do is add some chambers in a short row down to this page south, if you will. So I'll go back to add mode, and I'm gonna pop 2 chambers in here. I'm a little bit over my volume requirement, but you know, I've got a little bit of extra money in the bank on this project, so I'll leave those 2 chambers there. All right, so now we've got this atypical bed. What we can do, save current project, like the last one. I can email myself these parameters so I have them on file. And this pop-up is a great opportunity to showcase a few of our other design tools, being our water quality design tool, which helps us do designs for the Barracuda hydrodynamic separator. We also have a nyloplast basin configurator available that you can design a nyloplast basin in real time online, and you'll get inputs on whether or not some of those prefab stubs are possible. So just a little blip there about all of the resources that ADS offers. And with that, I can get back into HydroCAD to see how this chamber system can be modeled. So Hydraflow, excuse me. So similarly, we're going to have to define our parameters since Hydraflow does not recognize chambers on their own. So our invert elevation, again, this invert elevation is going to be the invert of our chamber, whereas this bottom elevation is the invert of the stone. So this will be 1161.75. Our rise will be 4.65. The arch shape still holds. Our span is 7.46. Barrel length 6.59. Number of barrels, we'll see, looks like we have 72 chambers and 12 end caps. So I'll consider 12 close to 10 and add 4 extra chambers to accommodate for the end caps. So we'll make this 76. Slope is 0, no headers. Stone encasement is yes. Our bottom elevation is going to be that 1161. The width, we can use our starting width of 9.08 and move from there. And our depth is going to be 6.75, again, from the technical note. So I'll hit apply. I see that my total storage is 3703. Now, that is quite a bit more than what I've gotten here. So either I made a typo, or I've, oh, my void is still at 100. Look at that. All right, let's check that out. All right, 2470, much better. So still have a little bit, about 1,400 cubic feet shy. So we can start bumping up that width to provide a model comparable to what our design is. So I'm gonna start at 10.5 and see how that looks. 22,390. So that's a bit higher than our 21,817. So we can go back and start messing with this to see if we can match our 21,817. So let's do 10.35. Still a little bit above. All right, we're getting pretty close now. 21,917. If anyone's uncertain, the number I'm looking for is this total storage value right here. in cubic feet. That'll be our total achieved volume at the top of the system. So now, also I just went a little bit below so I can start iterating between 10.10 and 10.05. I'll try 10.08. 21,822, we're 5 cubic feet over our target volume. To me, for the purpose of my project, that is acceptable. So I now have a model that represents this design I just created in our design tool. So that is what I have for modeling in the design tool and subsequently in Hydraflow.